At sea, wind turbines are really in their element. Here, where the wind blows unhindered, wind turbines produce up to 30% more power than on dry land. Little wonder then that far-sighted investors have turned their eyes towards the sea for both profitable and renewable resources. The challenge of going offshore is to build high-performance wind farms at low cost. Offshore, you have to beat the waves and the wind, and even the most trivial details, such as accessibility of spares, tools and minor parts, could turn into a logistics nightmare. That's why we at NEG Micon focus our attention on value chain management. We have developed a flexible, reliable and cost-effective method of planning, producing and installing offshore wind farms. NEG Micon is able to build offshore wind farms at any suitable site in the world using the same basic procedures and technology. As close as possible to the offshore site itself, we find a harbour where we set up a pre-assembly site. Here, lorries unload the parts for each section of the wind turbines. All turbines are pre-assembled at the harbour. Everything is done as fast and efficiently as when assembling turbines to be used on land, and we are less dependent on the weather at the offshore site itself. When all sections have been pre-assembled, they are lifted onto a jack-up platform and towed to the site of the wind farm. We use two kinds of jack-ups, one for loading and shipping of the different sections from the harbour, and a jack-up crane that lifts the sections into position at the offshore site itself. The two jack-ups stand firmly on the seabed when loading, unloading and installing the turbines, so everything is as steady as when installing a wind turbine on dry land. Offshore wind turbines from NEG Micon can be mounted on any type of foundation. In this case, we decided to use monopiles to which the turbines are bolted. The monopiles we use can be installed virtually anywhere in shallow waters. They have been approved by the DNV and they are designed to withstand the forces from the turbine and the sea as well as the pressure of ice. Though production of the monopile is a task that requires skill and precision, it's fast and fairly uncomplicated because we use standard materials, machinery and processes. Naturally, production is carried out in strict accordance with the ISO 9001 standard, as is the case with all other parts and sections for any NEG Micon wind turbine. The monopiles are carried by ship to the pre-assembly site, and since they are sealed off, they can be towed from here to the site offshore. At the offshore site, the monopiles are either driven into the seabed or cast in a drilled bore. Which method to use depends on the nature of the seabed. We therefore map the seabed with sonar and perform test drillings months before the installation. Divers also inspect the seabed to make sure there are no physical obstacles or findings of archaeological interest. In this case, the seabed was solid rock, so we drilled a bore from the jack-up platform at the offshore site. Once the bore was drilled, each monopile was filled with water, lowered into the bore and cast to the seabed with concrete. The monopiles used in this project are basically the same, only the length was adjusted to fit the exact soil conditions and water depth at each turbine location. The diameter of the monopiles here is 3.8 metres. They stand 16 to 19 metres down into the seabed and reach 10 metres above sea level. Once they are cast into the seabed, the monopiles are ready for the wind turbines themselves. Offshore wind turbines operate under very different conditions than the ones on dry land. The climate is always humid, salty and sometimes downright freezing. Special gaskets seal off the inside of every wind turbine, and a dehumidifier protects the turbine's mechanical and electrical parts from condensation. Outside, the wind turbines are treated with a special coating to prevent corrosion, but the basic high-performance technology is the same as in wind turbines used at land sites with the highest wind classification. rotor blades are made of advanced composite materials, so additional surface treatment is unnecessary. The final installation of the turbines is done in much the same way as on dry land. But since any offshore activity is done at high risk, we have to take extraordinary safety measures both during installation and maintenance. Every employee involved in offshore projects has to complete an offshore safety course that includes first aid, rescue operations at sea, resuscitation and survival skills. Every offshore wind turbine is equipped with a survival kit for maintenance crews that are trapped by sudden hard weather. The kit includes items like insulating sleeping bags and food supplies for several days. The wind turbines themselves are protected by markings, warning lights and other navigational aids, so they meet both local and international standards for unmanned offshore installations. We have benefited much from the safety standards of the oil industry, but since there are no generally approved safety standards for offshore wind turbines, we have had to develop our own manuals and procedures. We've done so in close cooperation with local authorities. In fact, NEG Micon is seated in the European Committee that draws up the first international safety standards for offshore wind turbines. Once the installation is successfully completed, the wind farm is connected to the public grid via a transforming station on land. A specially designed armoured sea cable connects the wind turbines to the transforming station. The cable is rated at 24 kV and designed to carry the full production of the wind park. Laying the cable and connecting it to each turbine is a job that requires extensive use of divers and special equipment. Close to the shore, where the waters are very shallow, the cable is buried into the seabed to protect it from ice. But at deeper waters near the turbines, the cable is simply lowered onto the seabed. The cable enters each turbine through a pipe that penetrates the monopile close to the seabed. The armoured sea cable also carries a fibre optic cord that connects an onshore server system to the turbine control systems. Since the server can be accessed through the public telephone network, our customers can monitor the entire wind farm using Windman or SafeNet, our wind turbine monitoring systems. Environmental aspects are some of the most important issues when building an offshore wind farm. We cooperate with local authorities and third-party environmental consultants, such as universities, to make sure that we carry out each project in accordance with the highest possible standards. One of the purposes of this cooperation is to draw up an environmental impact assessment at the very beginning of a project. This document discusses the wind farm's aesthetic and physical impact on the environment. Studies show that noise from the turbines and the magnetic field of the power cable do not have a negative effect on marine life. In fact, the foundation of the turbines become home to mussels and sea plants. Each megawatt installed saves the environment from at least 6 tons of sulfur dioxide, 5 tons of nitric oxides, 1,500 tons of carbon dioxide, and 110 tons of slag and fly ash. The conclusion is that an offshore wind farm has a positive effect on marine life and the environment in general. Finding the perfect site for an offshore wind farm is in fact a minor part of the entire project. Other matters, such as environmental issues, legal procedures and cooperation with local authorities, organisations and utility plants, are just as important. They can take up far more resources when building offshore. But since NEG Micon has more than 20 years of experience in the industry, our customers can put our knowledge to work and spend considerably fewer resources in the process. NEG Micon, for a powerful future.